Our story begins not with a bang, but with a whisper in the cosmic void. A whisper that grew into a roar, a symphony of creation played out across eons. It begins in chaos, 4.5 billion years ago, a swirling chaotic cloud of dust and gas, a nebula pregnant with potential. This was the raw material, the building blocks of our world, swirling in the aftermath of long-dead stars. This cloud was the leftover debris from the sun's fiery birth, a cosmic recycling bin of elements forged in stellar furnaces. Gravity, the architect of the universe, began to exert its influence, pulling this diffuse material together, dust to pebbles, tiny grains coalescing, pebbles to rocks, a slow, grinding process of accretion. Rocks to planetesimals, the seeds of planets taking shape. These nascent bodies, driven by gravity, collided with increasing frequency and force, growing larger and more massive in a violent cosmic ballet of destruction and creation, a chaotic dance of impacts and mergers. The result, a molten, red-hot infant Earth, a fiery crucible forged in the heart of the solar system, its surface a sea of roiling magma, a global ocean of molten rock. Then, a cataclysmic event. A Mars-sized object, Theia, collided with the young Earth in a glancing blow of unimaginable power, blasting vast quantities of debris into space, a cosmic spray of molten rock and vaporized material. From this colossal destruction, our moon was born, a celestial companion forged in the fires of planetary collision, stabilizing Earth's axial tilt, moderating our climate, and creating the rhythmic pulse of tides that would later shape coastlines and influence life itself. As the relentless bombardment from space gradually eased, Earth slowly began to cool, and a thin, fragile crust formed on the surface, a rocky skin over a molten heart, but volcanoes still raged across the landscape, spewing forth fire and ash, releasing vast quantities of gases and slowly forming a toxic, steamy atmosphere, a primordial soup of chemicals. Water vapor, released from the Earth's interior, began to condense in the cooling atmosphere, and thick, dark clouds formed, shrouding the planet in perpetual twilight. And then the rains began, a torrential deluge lasting millions of years, a planet-wide cleansing. Water pooled in the low-lying basins and valleys, carving out the landscape slowly, inexorably, forming the first oceans vast and unexplored. These primordial seas, rich in dissolved minerals and chemical compounds, became the cradle of life, a vast laboratory where the first sparks of existence would ignite. From a fiery volcanic hellscape of chaos and fire, Earth transformed into a world of water and immense possibility, a blue planet shimmering in the darkness of space. The moon's constant presence shaped the tides, stirred the oceans, and stabilized our planet's rotation, setting the stage for the emergence of life and the long, slow process of evolution. The first atmosphere was a toxic brew, a far cry from the air we breathe today. But within its chemical complexity, the seeds of something truly extraordinary were sown, waiting for the right conditions to sprout. The relentless rain sculpted the surface of the Earth, carving canyons and shaping mountains, filling the vast basins with water, and slowly cooling the planet's fiery crust. In these new oceans, teeming with potential, the next chapter of Earth's incredible story was poised to begin, a chapter written in the language of life itself. The stage was finally set, the players were in place, and the curtain was about to rise on life's first tentative appearance. For millions upon millions of years, Earth existed in a state vastly different from what we know today. It was a world dominated by rock and water, a landscape sculpted by relentless geological forces. The oceans stretched far and wide, their surfaces unbroken, seemingly lifeless and still. A vast, empty expanse under a hazy sky. Yet deep beneath the surface, in the crushing depths of the mineral-rich oceans, near hydrothermal vents spewing chemicals from the Earth's core, something extraordinary, something truly transformative began to stir. Simple organic molecules, the building blocks of life, formed and interacted in complex ways, driven by the energy of the planet. This intricate dance of chemistry eventually led to the emergence of the first single-celled life, prokaryotes, the ancestors of all living things. These pioneers thrived in an environment devoid of oxygen, drawing energy from the Earth itself through chemical reactions and the processing of minerals. They congregated and formed microbial mats, stromatolites, living fossils that offer us a glimpse into this ancient world, still found in places like Shark Bay, Australia. Then, a revolution cyanobacteria, also known as blue-green algae, evolved the remarkable ability of photosynthesis, harnessing the power of sunlight to create food and energy. Their byproduct, a waste gas to them, was oxygen, a deadly poison to the anaerobic life that came before, but a game-changer, a catalyst for the future of the planet. As cyanobacteria flourished and spread throughout the oceans, oxygen, this once scarce element, began to accumulate in the atmosphere, slowly but surely. This marked the beginning of a global transformation, a shift in the very composition of the air and the oceans. Life's first chapter was humble, almost invisible, but it would soon reshape the world in ways that were unimaginable at the time. The rise of photosynthesis marked a definitive turning point in Earth's history, unleashing a torrent of oxygen into the atmosphere, forever altering its composition. This new gas would trigger both a crisis for existing life and an unprecedented opportunity for new forms to evolve, driving evolution forward at an accelerated pace. The world, as it was known, was on the brink of profound and irreversible change. The next act in Earth's grand drama was about to begin, the Great Oxygenation Event, a period of dramatic atmospheric and biological upheaval. Oxygen from cyanobacteria first reacted with iron in the oceans, creating vast iron ore deposits. Only after these sinks filled did oxygen begin to accumulate in the atmosphere. This great oxygenation event triggered a mass extinction of anaerobic life, but opened new possibilities. Oxygen enabled the evolution of complex cells, eukaryotes, with nuclei and organelles. These cells likely arose through symbiosis, one cell engulfing another for mutual benefit. Mitochondria, our cellular powerhouses, are descendants of ancient bacteria. Eukaryotes formed the first multicellular organisms, simple colonies, then larger, stranger forms. The Ediacaran biota, Earth's first large organisms, appeared and vanished, paving the way for animal life. Oxygen's arrival was both catastrophe and catalyst, setting the stage for life's next explosion. The world was ready for a burst of evolutionary creativity. 541 million years ago, the Cambrian explosion transformed the oceans. Animal diversity exploded. Almost all major groups appeared. Trilobites scuttled, Anomalocaris hunted, and bizarre creatures like Hallucigenia thrived. Evolution experimented with countless body plans, creating vibrant ecosystems of predators and prey. Plants colonized land, evolving roots, stems, and waxy coatings to survive. By the Devonian, forests of primitive trees transformed continents. Arthropods ventured ashore, followed by lobe-finned fish evolving into amphibians. These pioneers took the first steps onto land, still tied to water but opening new realms. Life's conquest of land was a bold leap, reshaping Earth's surface forever. The stage was set for new evolutionary dramas. From ocean depths to forest canopies, life's diversity flourished. The world was alive with possibility. The next era would belong to the reptiles. After a mass extinction, the Mesozoic era began, the age of reptiles. Reptiles with scaly skin and shelled eggs thrived in the New World. Dinosaurs rose to dominance, evolving into a spectacular variety of forms. Sauropods towered, Stegosaurus defended, Velociraptor hunted, and T-Rex reigned supreme. The world was warm, continents drifting, and plants like ferns and conifers dominated. Marine reptiles ruled the seas. Pterosaurs soared in the skies. In the shadows, small mammals emerged, awaiting their chance. Flowering plants appeared, partnering with insects and transforming ecosystems. By the end of the Mesozoic, flowers and mammals were poised for their own rise. The age of dinosaurs shaped the world, but their reign would end in cataclysm. The next chapter would see life tested as never before. A new era was about to dawn. Earth's history is marked by mass extinctions, moments when life nearly vanished. The worst, the Permian-Triassic extinction, wiped out over 90% of marine species. Massive volcanic eruptions triggered global warming and ocean stagnation. Later, a giant asteroid ended the reign of the dinosaurs, unleashing firestorms and blocking the sun. Food chains collapsed, the non-avian dinosaurs and many others disappeared. Yet, extinctions create opportunities. Mammals, once small and secretive, survived and diversified. The Cenozoic era, the age of mammals, began. From catastrophe, new life flourished. The world was open for new rulers. Our own ancestors would soon step into the light. The story of mammals was just beginning. With the age of dinosaurs a distant memory, the world stood silent, ready for a new chapter. The colossal reptiles, once rulers of the earth, were gone, leaving behind a void in the planet's ecosystems. Mammals, small and often overlooked in the shadow of the dinosaurs, seized their chance in the Cenozoic era. This new geological epoch presented an unprecedented opportunity for them to flourish. They diversified, rapidly evolving into a myriad of forms, filling ecological niches left vacant by the dinosaurs. Some returned to water, adapting to marine environments and eventually evolving as whales, masters of the ocean depths. Others took to the air as bats, developing sophisticated echolocation systems and conquering the night skies. And many grew large on land, becoming the megafauna that roamed the continents. The continents drifted, slowly reshaping the world map and influencing climate patterns across the globe. Climates cooled, ushering in periods of glaciation that sculpted landscapes and tested the resilience of life. And grasslands spread, transforming ecosystems and creating new opportunities for herbivores and their predators. This spurred new evolutionary paths, driving the development of specialized adaptations and behaviors. Grazers and predators evolved, locked in an arms race of survival and adaptation. This created dynamic new ecosystems, complex webs of life where every species played a crucial role. Among mammals, primates took to the trees, finding refuge and opportunity in the forest canopy. Developing grasping hands and larger brains, they began to explore new ways of interacting with their environment. As forests shrank due to climate shifts and geological changes, some primates moved on to the savanna, venturing into open grasslands in search of new resources. Walking upright, bipedalism, became a defining characteristic, a pivotal adaptation for survival in this new landscape. This freed their hands, allowing for new forms of manipulation and interaction with the world, and sparked a cascade of evolutionary changes, setting the stage for the emergence of humankind. Tool use, bigger brains, the ability to learn and adapt, and complex social behaviors followed, fostering cooperation and innovation. The journey from ape to human, a long and winding path of adaptation and change, began on the African plains, in the heart of the cradle of humankind. Environmental change drove innovation and adaptation, pushing our ancestors to their limits and shaping the course of human evolution. The stage was set for the rise of our own species, a species destined to reshape the planet. The next chapter, humanity's story, is about to begin. The world was ready for its most transformative inhabitants, a species capable of both great creation and profound destruction. For 2.5 million years, Earth has cycled through ice ages and warmer periods. Early humans adapted, hunting ice age beasts, mastering fire and making clothing. Homo sapiens emerged in Africa, spreading across the globe. We outlasted other human species thanks to language, cooperation, and culture. Around 70,000 years ago, we began our global migration, reaching every continent. Our adaptability and culture fueled our success. 12,000 years ago, agriculture began, leading to villages, cities, and civilizations. Populations grew, technologies advanced, and societies became complex. In a blink of geological time, humans transformed the world. Our impact would soon reach planetary scale. The story of civilization is just a moment in Earth's vast history, yet it would change the planet forever. The Industrial Revolution unlocked fossil fuels, powering cities and technologies. Human populations soared and we became a global force. But this success came at a cost. Greenhouse gases warmed the planet, altering climate and weather. We've transformed over half the planet's land, driving species to extinction at an unprecedented rate. Scientists warn we are entering a human-driven mass extinction, the Anthropocene. Our actions now shape Earth's future. Understanding Earth's deep history is vital. The planet is a system of interconnected parts: climate, oceans, life. We are both product and custodian of this immense story. By learning from the past, we can guide the future. The choices we make now will echo for generations. The story of Earth is our story. The next chapter is up to us.